Okay, sulfuric acid, as I told you, is a very widely used chemical. It is used in the industry, a lot of chemical uses. Now, how it is prepared? So please write down sulfuric acid. It is prepared by contact process. The Haber process for the ammonia, and this is called contact process. Okay. In the contact process, as I told you, it has 3 steps. Number 1, step 1, we have to take the sulfur. We need sulfur. In the step 1, sulfur is burned in excess of oxygen. And where is it is obtained? It is obtained by, you have to tell the source, as we told about the contact process, nitrogen. It is obtained by the roasting means burning, heating, metal ores containing sulfur. Like, they can ask you the name as well. Like, one is copper pyrite, formula is CuFeS2, or zinc blende. ZNS. First step, sulfur burns in oxygen to form what? Sulfur dioxide. That is the first step. Where the sulfur that is obtained from the ore, it is burned in excess of oxygen to form out. Sulfur dioxide is purified, and then in the stew, which is the main steps. Step 2, the sulfur dioxide is purified. The one that is prepared, it is purified. The sulfur. Okay, so in the second step, sulfur dioxide is purified and oxidized again. To form SO3. And this is the main step. In this step, look at this. This is the main step of the preparation. But if you look at the reaction, you will understand why we are discussing it here. It is oxidized to form what? Sulfur dioxide. So it is, what type of reaction is this? Reversible reaction. And if I look at the delta H, that is going to be, let's say, minus 88 kilojoule per mole. Right? Now you have to tell me the reaction conditions for this. You have to tell me the reaction conditions for this. What do you think? The reaction conditions. Temperature should be low or high. Temperature should be low or high. What do you think? Low temperature gives better yield of sulfur trioxide because it's an exothermic. But what if you look at the temperature 450? Then why we kept it 450? Because the low temperature is going to lower the speed, which we cannot afford. So we have to find a temperature which is compromised between speed and yield, right? Where there is a compromise with the best yield and the best speed. So you have to write this, okay? I'm not going to write it again. I'm going to put a star here. So the same explanation we have put on the top. Pressure. What should be the pressure? What do you think? It is happening in a closed container. What should be the pressure? Should be high, should be low. The number of moles of gas is 2 on this side, 3 on this side. So should be what for the better yield of sulfur trioxide? Should be high to get to the equilibrium to the right side where the less moles. But again, high pressure is what? Expensive to achieve. So even then, over there in contact process, we use 100 to 200 ATM. We don't need even that. 101 to 2 ATM is enough. Catalyst. What is the catalyst? The third one. The catalyst. V2O5, vanadium 5 oxide is the catalyst. Got it? So these are the 3 conditions for the step 2. Now step 3. This sulfur trioxide gas that is prepared, if you add it into the water, it gives you H2SO4. You know, sulfur trioxide added into the water gives sulfuric acid. This is what we were preparing for, but there is a problem with this. Because the reaction is happening on a large scale.
कैटलिस्ट का नाम क्या लिखा है?
Vanadium 5 oxide, vanadium pentoxide, V2O5. So as the reaction is happening on a large scale, this is highly exothermic reaction. What is this? Highly exothermic. Okay. Fuming sulfuric acid is produced. Okay. Fuming sulfuric acid is produced, which may be a safety hazard. You know, sulfuric acid is a very strong, very corrosive. So if such a highly exothermic reaction, the boiling sulfuric acid, the fumes of sulfuric acid, they may damage your skin, they may damage your clothes, they may damage your material around. Hence, what to do? There is alternate way. There is an alternate route. And what is that alternate route? This is interesting. Instead of adding sulfur trioxide directly into the water, this sulfur trioxide gas is passed into already prepared sulfuric acid, the concentrated sulfuric acid, the already prepared. So you must have sulfuric acid already prepared. That sulfur dioxide is added into the concentrated sulfuric acid. and then it becomes H2S2O7, another compound which is known as oleum. What is oleum? Oleum is nothing else. It is just the concentrated form of sulfuric acid. Concentrated form of sulfuric acid. Let me give you an example from common life, just for the sake of analogy. If I have an orange juice, I heat it, the water evaporates, the juice is getting thick and thick and becomes a pulp-like thing. And if you keep on heating, it's all dried, becomes a tang-like thing, powder. Then you add water, it becomes the orange juice again. So this is what the oleum is, just like a pulp or a concentrated form of sulfuric acid. Okay, this is oleum. So how you get sulfuric acid back from oleum? Just add water. So H2S2O7 plus H2O gives us what? H2SO4. Okay, so this is sulfuric acid. Okay, so this is how we prepare the sulfuric acid. That actually there are three steps. Now I sum it up. What I'm trying to say, that sulfur in the first step turned into what? Sulfur dioxide. That is the step one. In the second step, which is a reversible, sulfur dioxide turned into what? Trioxide. In the third step, the sulfur trioxide has to be turned into what? Sulfuric acid. But going direct is a risky. So we have to, if you have been preparing in the lab, that won't be a problem. In the lab, we have a small scale that was not that much sulfuric acid fuming, because that it's not producing that much heat. But when it's happening on the large scale, the big containers, they are going to produce so much vapors, so much heat, that becomes a safety hazard. So we avoid and we go bypass. Bypass means alternate route. So instead of adding into water directly, what we do? We use the already prepared sulfuric acid. It becomes oleum, and then this oleum is added with water to become sulfuric acid. So there are three steps. Just we are alternating the third step to prepare the sulfuric acid, right? So this is how we prepared the sulfuric acid in three steps known as contact process. And this one is the main step where reversible reaction is taking place. For the battery yield of ammonia, we have to the class time. Thank you.